Okay. Hi again. So now let us continue with electric circuits. So this is term 3 work. So I have another question here. Okay. I have another question here. 8.1, they want Ohm's law. So we start with definitions. Okay. They say state Ohm's law in words. What does Ohm's law say? Okay. So it says what? Uh, it says the potential difference across the ends of a conductor of a conductor. Is directly is directly is directly proportional is directly proportional to the current flowing through through that conductor at a constant temperature. At a constant temperature. Now, so that's Ohm's law. Okay. Let's go to, so we have to read the question first, isn't it? Before we start answering. So now let us read the question. Eh? They say what? The battery in the circuit below has an EMF of 5 volts. So an EMF of 5 volts and an internal resistance R. The resistance of the connecting wires and ammeter can be ignored. So internal resistance R and EMF of 5. Now they say switch S is closed, okay? And the ammeter reading is 0.4 amperes, okay? So they give us the ammeter reading here when switch S is closed, okay? So you should remember that it makes a difference if the switch is open or if it's closed. It's not the same thing, isn't it? Switch being open and switch being closed, it makes a difference. If the switch is open here, then the current will not come this side of the parallel branch. We close the switch here, then we have a parallel connection, 8 and 6. Now they say calculate the reading on the voltmeter. Voltmeter is here. When the switch is closed, there will be the voltmeter, so there will be the current that moves in the circuit, okay? There will be the current that moves. If the current is moving in the circuit, the voltmeter here will read the external voltage. and V external on the equation of EMF. Okay. Now, what do we know? V external, there are only two resistors externally. Okay. So we have to find the what? The external resistance here, because there is only two resistors. So we can say 1 over Rp equals to 1 over 18 plus 1 over 6. So this will give us, so this will give us 2 over 9. Okay, so this is 1 over Rp. So if we want Rp, we take the reciprocal. So this comes, it becomes upside down. So then Rp will then be equal to 9 over 2, which is equal to 4.5 ohms. And then we can find the V external. So V external equals to I multiplied by R external. So equals to 0.4 multiplied by 4.5. So that is going to be equal to, okay, then you use your calculator here. Then you get, so it means V external is 1.8 volts. Okay. So we have our V external here. So this is the reading on the voltmeter. Okay. So we had to understand what we're being asked, isn't it? Because the question is saying the reading on the voltmeter. We have to know that if it's like that, then it means the reading on the voltmeter is the V external. Okay. Now 8.2, they say energy dissipated in the 18 ohm resistor in 5 minutes. Okay. Now the energy, okay. The equation of energy is what? I gave it to you the other time. I said E equals to P multiplied by delta T. Okay. And then the power here, the power is V squared over R, and then it's going to be multiplied by the time. So if they give us minutes, they give us minutes, so it should be converted into seconds, isn't it? So then you substitute. So you have what? V here is going to be 1.8 and then squared divided by 18. Then 5 minutes, it's going to be 5 multiplied by 60. It's going to be equal to. So you use your calculator here. So it's going to be I get 54 joules. The unit is joules for energy. Okay. And then 8.2.3, they want the internal resistance of the cell. Okay. Internal resistance of the cell. Okay. So we're going to use the equation for EMF because we are given the EMF as 5. So here we're going to say EMF equals to I, then R plus R. So 5 equals to, and then the I we're given as 0.4, and then it's going to be plus R. The R that we have here is the one that we calculated, the one that we found from the parallel connection. So it's 4.5. Okay. So then we have 4.5. 4.5 here. And then we can make R the subject, isn't it? So, okay, we divide by 0.4. Okay. We divide by 0.4 here. So it gives me 12.5 equals to 4.5. And then plus R. So this means that R will be equal to minus 4.5. Then this is going to be equal to 8 ohms. So now 8.3. Okay, let me do it here. Let me do it this side. 8.3. They are asking, how will the reading on voltmeter V change when the switch S is opened? Choose from increases, decreases, or remains the same. Now, this is where you have to understand the impact of resistance on the lost volts. Okay, so the lost volts, which is what? Which is I R. So small letter R, IR. Okay, so this thing is V internal. Understand? We can see here that if the total current goes up, there is more lost volts. Okay, so this means that the reading on the voltmeter will decrease. Okay, if this becomes more, so now if we if we open the switch here, if the switch is open, the resistance becomes 6. So it means that the external resistance is no longer 4.5, it's now 6 ohms. Okay, so the total resistance has gone up. Okay, the total resistance has gone up. Then what will happen to the current? The current will go down. Okay, the current will go down, so there is less volts. So we are saying that it will decrease. So it will be decreases. Yeah. Let me try to explain. Although we are not required to explain here. Okay. The equation is like this. Okay. Let me erase this. It will decrease for the following reason. The equation for EMF is E equals to V external plus V internal. V internal is what? Is I R. So if we rearrange the equation, then what happens? We have E minus IR equals to V external. Okay. Now, V external, this is the reading on the voltmeter. Okay, that they're asking. So if the total resistance goes up, means the current will go down. The current here will go down. Okay. If the current goes down, this will go up. If the current goes up, this will go down. Okay. So the current went down, so yeah, it will increase. So this is thinking, it will increase, not decrease. So this is increases. So it increases because the current has gone down, because the total resistance has increased. So the current will go down. Okay, so this means that there will be less lost volts. Okay. So this will go down. So if it goes down, then this will go up. So the answer will be increasing. Sorry about that. So the answer would be increases in this case. Okay, so leave your questions in the comments. Okay, and let me know the parts that you did not understand. Oh, sorry, by the way, this is 8.2.3. I did not. This is 8.2.3. I did not number that. Yes. Let's leave it for now. So leave your questions in the comments. Let me hear your concerns. Okay. Cheers.